Okay, we're going to talk about congruency and similarities. And with this, we need to look at some notation. And one of the symbols that we use is this little squiggly line to denote similar objects. Similar objects have the same shape, but not necessarily the same size. So let's look at a couple of similar objects. So this triangle would be similar to another triangle, but what would happen is if I would, well, no, let me start that over. If I did this, and let's do this. So these are similar triangles because notice that the angles are the same, but the sides are not the same. So similar triangles are the same shape. And the reason why I say that if I do this, notice these are no longer really the same shape because this is an equilateral triangle and this is not. So this is not a similar triangle, whereas the previous one was. Okay, so remember, if I do this and enlarge, these two are still similar triangles. And so that's what similar objects mean. Now, congruent objects have the same size and they are similar, so they have same shape. And that is where we have the equals with the squiggly line on top. Those are congruent objects, same size and similar shape. So these right here would no longer be congruent, but now then these two are congruent. And so if I were to rotate this, these two are still congruent, even though they don't look exactly alike, because they are similar, they have the same shape, and they also actually have the same size. Each of their sides are 43 inches, or units, and they're 60 degrees. Now let's look at a couple of other shapes. I'm going to look at a trapezoid, and I'm going to bring it down. And I'm going to look at another trapezoid, and I'm going to bring it over, okay? And let me angle it like this. These are congruent because if you notice, I have the angles being the exact same. The lengths will be the exact same. They're just turned differently. So that is what congruent means. Now, if I were to take this one and enlarge it, now they're just similar to each other. And so that is the difference between similar and congruent. Now, if I look at line segments, two line segments are only congruent if they have the same length. Okay, so this line segment has a length of 87 units. Now, if I want to do another line segment from here to here, this one has 90 units, so they're not congruent yet. Now then, this is 87 units, and This one is 87 units. So now these two are congruent. As long as they have the exact same, it is congruent. Otherwise, they're just similar. Two angles are only congruent if they have the same measure. So just a few moments ago, where I was talking about the triangles, and I'm actually going to do a couple of polygons here. And so let's see here. Nope, did not get. Nope, I need to get a different one. So, and I apologize for my dog barking. Okay, so these two angles, now notice angle A and angle B are actually congruent, because if you look over here at the angles, they're congruent because they have the same measure. So actually all of these angles are currently congruent. Now if I were to take this and do that right there, I do still have some angles that are congruent. Angle F, angle A, and angle B. Those three angles are still congruent, but the others are not at this point because they are no longer the same measure. So in order to be congruent, and recall, congruent means it has the equals with the squiggly line above it. Congruent means they're the same, exact same thing, equal to each other, okay? And so it has the equal sign, then they have to have the exact same values. Otherwise, as long as they have the same shape, they are similar objects. And that's going to be the big difference there.